Hello, good morning everyone. Today I'll be talking about the topic beams and analysis of the beams. So these are the subtopics which will be covered in this module. These are introduction, static equilibrium, types of support, free body diagram, shear force and bending moment in the air. So let's get started. First of all, we'll be talking about what is a beam. So a beam is nothing but a structural member that carries a load that is applied transverse to its length. See, for the further explanation, I'm having an object over here which looks like a beam. As you can see, a beam is a longitudinal member, which means its length is much greater than to its width and the thickness or the depth, you can say. So basically, an axis which will be passing from the centroidal of this plane will be called as a longitudinal axis, and the axis perpendicular to this axis means this axis will be referred as transverse axis. So it is a structural member that carries a load that is applied to the transverse to its length or perpendicular to its longitudinal direction. So as we all know, beams are generally used in floors and roofs, and sometimes called a floor joist, stringers, floor beams or girders. In a diagram, I have plotted a same diagram in which a beam is supported on two columns, as you can see, and three persons are standing over there. So the white guy, red guy, and the other girl standing over here is not representing nothing but a point load, as they are occupying very less area in a very a very less area, and their weight is acting as a load over the beam. So moving ahead. So this is a diagram which is showing some building frame in which you can see different beam, girders and column. This is actually showing how the loads are initially applied to the building surface and that are transferred to beams which transfer the load to the another building component, that are girder and column, and finally to the foundation, and at the end it goes to the soil. So in order to analyze the beam, we first need to understand static equilibrium. So what is a static equilibrium? For example, there is an object over here, as you can see, and some red and blue forces are applied on it. Blue and red forces are nothing but a point load. So as you can see, there is a downward arrows, left side arrow, right side arrow, and similarly like that. For example, this is an object same over here. If I apply this blue force over here like this, and there is another force, blue force in upward direction. So as you can see, these two forces, if they are equal in magnitude, will counteract each other impact. So due to which its position will not change, it will remain stationary. So before and after application of load, if the position is same, or you can say stationary, it will be considered that the object is in the static equilibrium. So in our analysis or even a design of a beam, we basically consider that our beam after the loading will not change its position, or we can say it will be under equilibrium. So for this condition, all the forces which are subjected in vertical direction, lateral direction or longitudinal direction, or the moments which generate through the forces should be counteracted by the supports. So let me get straight to some terminologies. The forces or loads applied to the beams from the roof or floor must be resisted by the forces from the beam supports. The resisting forces are called reaction forces. The forces often referred to as a vector because it has magnitude as well as direction. Through the diagram you can see the red arrow is nothing but the applied load on the beam, and the beam is supported on two columns which are generating a reaction force, that green arrow, in upward direction. Correct? So moving ahead, the reaction forces can be linear or rotational, which we'll be studying ahead. The reaction force is also called a shear reaction, and the rotational reaction is often called a moment. The reaction force must balance the applied force. So that's what I've said earlier. If there is a beam and if there is some load applied over it, there should be sufficient support to counteract the effect of this force. This force can be linear reaction, which is called shear. Shear is nothing but if this is the cross section of the beam. If the force direction is parallel to the cross section of the beam, if there is an upward force, definitely it will be the parallel to this beam cross section, that it will, then it is called as a shear force. And due to this shear force, the moments will be generated. Those are things are interrelated, which we'll be studying ahead. So first I will like to inform you or tell you about the types of support that the beam is rested over. So there are basically three types of supports, as you can see. One is roller, one is pin connection, and first is fixed support. So in order to understand these three types of support, let me illustrate you such a demo. For example, this is your beam and it is simply supported over a roller. Simply consider my hand as a roller support and it is simply supporting over it. As you can see, if I apply some horizontal load, it is moving, and if I apply some vertical load, it is rotating. But if I apply any vertical load, it is not changing its position. So this is how roller support works. It can generate reaction only in vertical direction. Else if you give a support, or else if you give a load in a horizontal direction or any rotation is produced, it will not be able to resist it. So the roller support is the one which gives reaction only in one side, that is vertical reaction. Coming on to the next support, that is hinged support, it is much advanced than the roller support as it can give reaction in all the directions but cannot stop rotations. For example, the same object I am taking and I am somehow holding it in my hand like this. Now as you can see, if I apply a vertical load, it is not going downward, it is resisted by some reaction in vertical direction. Similarly, if I apply a horizontal load, it is not changing its reaction because the reaction is produced by my hand, but there is some rotation, it is free to rotate about my hand. So basically this is how the hinged support works. A beam which is supported by hinged support can rotate due to some moments produced but cannot change its position. And the final support is the fixed support. As the name suggests, the beam cannot move or either rotate through its point if it is supported by fixed support. Simply, I'm again taking this object and this hand is working as a now fixed support. Either you apply a vertical load, horizontal load, or any kind of rotation is not allowed by the if the beam is supported on the fixed support. So moving ahead, there is a second diagram also here which are showing some forces with their respective symbols. The F stand for forces, the reaction forces, and the XY, the subscript denotes the direction of the force. As you can see, roller is generating a simple Fy upward. That means a reaction force in upward direction. The hinged connection or pin connection is producing two forces, one in X direction and in Y direction, and the third support, fixed support, is producing X direction, Y direction, and additionally a moment which will resist the rotation as well. So depending upon the beams on which they are supported, types of supports, beam can be classified as follows. So the first type of beam is a simple beam, which is also called as simply supported beam. In simply supported beam, one end is hinged and one end is free roller support, as I've denoted through the arrows. As we know, hinged, already I've said that hinged always gives two reaction, one in X and Y. So both of the arrows denote that Fx and Fy, and on the another end there is only a roller support which is only giving Fy reaction. So the first type of beam is simply supported beam. In it, one end is hinged and one end is roller. And the second type of beam is continuous beam. A continuous beam is a type of beam in which the beam is supported over two or more than supports, two or more than, 3, 4, 5. There can be as many supports and the beam is resting over it. So as you can see in the second diagram, one end is a fixed support, one end is a hinged support